everyone, welcome to Samadhan Life Science. Today we will discuss about chemical equilibrium, especially the relation between equilibrium constant and thermodynamics. So to start with, we will first consider a general reaction. So small a mole of A plus small a mole of B is reacting together to form small c mole of C plus small d mole of D. Now for the equilibrium constant, we will write the constant in concentration form. Kc is equal to activity of C to the power small c, activity of D to the power small d divided by activity of A to the power A and activity of B to the power B. Now the equilibrium constant we can also write in pressure form, which is Kp is equal to partial pressure of C to the power C into partial pressure of D to the power D divided by partial pressure of A to the power A and partial pressure of B to the power B. Now we can connect these two equilibrium constant with a simple equation, which is Kp is equal to Kc into RT to the power del N. Now this delta N is the difference between moles of reagents and products. So we can write delta N is equal to moles of products which are in gaseous state minus moles of reagents which are also in gaseous state. So for delta N, we will only consider the products and reagents which are in gaseous state. For example, if we have this reaction, calcium carbonate, which is in solid state, is dissociating to calcium oxide, which is also in solid, plus CO2, which is gas, then the delta N is 1, because for these two we will not consider any N equal to 0, or we will just ignore the solids and liquids. But if the delta N becomes 0, then Kp is equal to Kc. How? If we have this reaction, hydrogen plus iodine to forming Hi, and all of the reagents and products are in gaseous state. Now I will first balance this equation and then we will calculate delta N, which is 2 minus 1 minus 1, right? So 0. So for this type of reaction, Kc is equal to Kp. Now in this equation, R is gas constant, whose value is 8.314 joule per mole per Kelvin, and T is temperature, which we will always consider in Kelvin unit. Now we can again relate this equilibrium constant to thermodynamics by free energy. So the change in free energy delta G is equal to delta G0 plus RT ln Q, where Q is reaction quotient. Now when the reaction is at equilibrium, then delta G is equal to 0 and Q we will consider as equilibrium constant K. So we can write delta G0 is equal to minus RT ln K. This is the relation between free energy and equilibrium constant. Now if the value of K is greater than 1, then this ln K part become a positive, then overall the delta G becomes negative, which means the reaction is spontaneous or favorable in this condition. Now if the value of K is less than 1, then overall the delta G is positive, which interprets that the reaction is non-spontaneous or unfavorable in this particular condition. Now let's take example from your previous year questions. So for the first question, at 300 Kelvin, equilibrium constant Kp for this production of ammonia is given. We have to calculate delta G. So we have the equation delta G0 is equal to minus RT ln K. So we'll put the values. R is given here 8.314 into T is 300 Kelvin into ln. Kp is given here 4 into 10 to the power minus 5. So this will come around 25 kilojoule per mole. Now see here that 25 kilojoule is positive value here. That means this reaction is not spontaneous. In reality also industrially, for the production of ammonia by this process we need high pressure and catalyst. So the value matches with the condition. Now for the second problem, for the reaction of dissociation of PCl5, Kc is given. We have to calculate the Kp at a definite temperature. Now the equation is Kp is equal to Kc into RT to the power delta N. So let's first consider delta N. So all the products and reagents are in gaseous state. So 1 plus 1 minus 1. So delta N is 1. Now temperature is given in centigrade. So we have to convert it in Kelvin. So 250 plus 273, 523 Kelvin. Now let's put the values in the equation. So 1.6 for Kc into R. Now see here, the value of R is different here than the previous problem. Why? Because the units are different. So you have to be careful. Okay. So now 0.0821 into temperature is 523 to the power delta N is 1. So this will come around 69. So I hope you understand now equilibrium constant and delta G calculation. So I hope this helps you in solving the problems in your GATE Excel exam. Thank you for watching. See you in the next video. Bye bye.